once again we're given the integral of f of x from 0 to 16 dx. We want to know what that is, and we're given this table. We know that there's going to be 4 equal subintervals, and this time we're going to use trapezoidal approximation. So to approximate the integral of f of x from 0 to 16 using trapezoidal approximation, it looks pretty similar to, I equals 1. It looks pretty similar to the ones we've done before. It starts out with f of ci, just like normal. But instead of just delta x, we're going to use delta x over 2. And when we use the subintervals, instead of just using like just the right one or just the left one, for this will be our first subinterval, we'll use every point. So our delta x is found the exact same way. It's going to be b minus a over n. Our b is 16, our a is 0, and our n is 4. So our delta x is equal to 4. Now we're going to find our 4 now that we know delta x. So R4 is equal to, so we know these are our 4 subintervals from 0 to 4, 4 to 8, 8 to 12, 12 to 16. And our delta x for each one of those is 4. The difference is 4. So instead of like a left endpoint where we'd use 0, 4, 8, and 12, 0, 4, 8, and 12, or a right endpoint where we'd use 4, 8, 12, and 16, for trapezoidal we're going to use all of them. So we're going to use f of 0 plus f of 4 plus f of 8 plus f of 12 plus f of 16. And we're going to multiply that by our delta x over 2. So that's going to be equal to 5 plus 3 plus 9 plus 11 plus 2 times 2, which is going to be 30 times 2 is equal to 60. And that's going to be our answer.